All right, everybody. This is going to be the first part of the Chapter 7 notes on sampling distributions. So we're going to talk about a couple definitions and look at a couple examples and go from there. So first big definition is the difference between a statistic and a parameter. And the biggest difference is a parameter. Easiest way to remember this is parameter starts with a P, which represents population. S stand for statistic. So that think of the S as sample. So a parameter is a number that describes some characteristic of the population. So again, think of the P's. A statistic is a number that describes some characteristics of the sample. So for example, here in the first one, we're looking at 1,102 randomly selected 12-year-olds in the United States, and if they have a cell phone or not. So here, your sample is the 1,102 randomly surveyed 12 to 17-year-olds. Statistic is the sample proportion that we find. So that's 0.71 to 71% that said yes. Okay, that's the number that describes the population. And then we have your population, which is all 12 to 17-year-olds in USA. And the parameter that we're trying to find is P, right? The proportion. Proportion of all 12 to 17-year-olds who own a cell phone. So again, P, think population, S, think sample. And then our sample in this case is the people that we surveyed. And then what did we find? What's the thing that describes this population is the 71% that said yes. Compared to the population, which is all total 17-year-olds, and this parameter being the true proportion of people that own cell phones. So it's a little example. Take some time, look at the next one on your own. We can kind of go over that in class. Okay, so now leaving to some more definitions. What is sampling variability? Sampling variability is the value of a statistic varies in repeated samples. And what this is basically saying is that if you were to let's say you're rolling a dice, right, and you look at the number of heads that roll, the number of threes that show up when you roll a dice 10 times, right? Each time you do this, each time you roll 10 dice, you're going to have a different number of threes, right? So there's going to be some variability in the statistic itself that you're looking at. So what we're saying is that each random sample will produce slightly different values or means, right? X bar. So we need to look at the variability in the sampling statistics. Right? And if you think about it now, each time we do this, we're going to have a different kind of sample. And if you put all those samples together, you're going to get a distribution itself, which is what a sampling distribution is. So it's the distribution of values taken by the statistic in all possible, and let me highlight the word all, samples of the same size from the population. Okay, we need to look at a range of values and its shape, possible sample statistics to see the full picture. All right, so each time you do this, you're going to get a slightly different answer. We can combine all those different answers together to make a little distribution, and then you can look at probabilities if the the distribution is normal. Then we can look at probabilities by using z-scores and do all the stuff that we've already learned. That's kind of the idea behind this whole unit is, okay, we're going to take a sample and look at one specific value of it, whether it's the average, like the X bar, or a percentage or proportion, and look at the distribution of all those samples, and then kind of compare that to the population and see what we can determine. So we'll kind of talk about this problem here in class, the next one. And the key, like I said before, I highlighted the word all. You have to look at all possible ways of sampling two different things, or of all possible samples. So here we have 4 as our population. We want to choose 2, taking a sample of 2. So we need all possible combinations of 2 out of these 4 numbers when I'm looking at this problem here, which we'll kind of talk about in class. Okay. I'm going to skip this problem. This one that we can do in class. I'm going to skip down to the bottom of this one. So what is the difference between the distribution of a population, the distribution of a sample, and the sample distribution of a sample statistic? So a couple things to write here. So a population distribution is the values of the variable for all individuals in the population. Okay. Distribution of a sample shows the values of a specific variable for the individual. In the sample, we record a value for the statistic. Okay, that leads to our next definition, which is an unbiased estimator versus a biased estimator. You can kind of guess what this is just based on the definition or the word. So an unbiased estimator is when your sample statistic is equal to the population mean or population parameter. So a statistic used to estimate a parameter, so again, parameter being population, is unbiased if the mean of the sampling distribution is equal to the value of the parameter. So here we can write X bar equals mu. And biased is when the center of the sampling distribution, and kind of guess what this is going to be, is not equal to the population parameter. So how can you reduce the variability statistic? You can increase the sample size, which can be pretty much the biggest way. So how do you reduce the variability of a statistic? Well, let me talk about what the variable of a statistic is, and then we kind of talked about already. We'll kind of do a refresher, and then we'll go into how to reduce it. So the variability of a statistic describes the spread, describes the spread of the sampling distribution which is kind of like our general definition of like standard deviation. And it is determined by the size of the random sample. So how do you reduce this? By increasing the sample size. So larger samples equals smaller spreads. There's one caveat to this. We kind of thought about this in chapter 6, we need our population size to be at least 10 times larger than the sample. So this is the independence condition that we've talked about before. And so what impact does the size of the population have on the variability statistic? It doesn't, as long as you have this condition. So have an impact as long as the population is at least 10 times larger than the sample. And this again implies independence. Okay. Now, last question in this video before we get to 7.2. So what's the difference between accuracy and precision? So I'm going to give you the verbal definition. I'm going to show you some pictures that will help. So accuracy measures what you're supposed to have. It is supposed to, right? And so this is related to bias. You have precision, which is how close values are to one specific value. So think of this as variability. Okay. And you guys have probably seen these pictures before, but if I draw these, so plastic dartboard. Draw 4 different ones here. All right, so the first one, if I draw some dots in here, so I'm going to do something like this. Right, again, bullseye, the thing in the center is where you want to be. So this here is we have high bias because we're not measuring what we need to, right? We're not close to the bullseye, but our points are bunched together pretty closely. So this is high bias, low variability. So okay. So the next one I'm going to draw is high bias, high variability. And this is something like, so you're not even close, and then we have a lot of spread at these points. Something like this. Right, so this is high bias, high variability. Next one I'm going to do is low bias, high variability. So again, we're going to be close to where we want to be, but we're going to have a large spread. So something like this. This is low bias, high variability. And then the best one obviously is going to be low bias, low variability, in which you just have a bunch of dots kind of bunched together in your bullseye. So this last one. So that's it for this video. Again, we're going to look at that the big problem in this in this section in class. But it's kind of just some basic definitions. As always, if you guys have questions, let me know. But if not, have a great rest of your day.